All right, so today we're in section 11.2, reflections. If you guys remember, now we only touched on it, okay? So in 11.1, this chapter is transformations. And then in 11.1, we learned translations. Now in 11.2, we're learning a second type of transformation, a reflection. Does anybody remember? We only said it very briefly. We didn't even write it down. Does anybody remember what our key word was for reflection? I think I talked more about it in 6th hour than this class. So with a reflection, it is a flip. A reflection is a flip. It's a type of transformation that flips, and it is reflected across either the X or the Y axis, which I call the line of reflection. All right, now what I have in bold here, this is like my key to crack the code, you could kind of say. All right, to reflect across X, I take the opposite Y value. To reflect across Y, I take the opposite X value. And I'm going to show you what that means. This is not one of the graphs that you're doing, but I'm going to show you on the graph what we're talking about. All right, I need you to write everything that's in words on your paper. Okay, everything that's in words I want you to write on your paper.
That's in words.
All right, so we're writing everything but the graph. Everybody doing okay? All right, just about done. So we're going to look now at one original ordered pair. Our original ordered pair is -4, 4. Does everybody see that where we have it listed? Our original ordered pair is -4, 4. So my rule says if I want to reflect it across the x-axis, I must take that ordered pair and now do the opposite of the y value. The x value stays the same. So now it becomes -4, -4. Okay? So to reflect across x, I do the opposite of my y value. It was 4, and now it's -4. Okay? So let's see what it looks like on the graph. Again, this is not a graph that you have to do. I just want you to look up here. If I plot my initial point, -4, 4, help me figure out where it goes. Do I go left 4 or right 4 on X? Left 4, then do I go up or down?
Down.
Whoa. +4 for the Y, over there. So I go up 4, and here's where my initial point goes. Okay, everybody with me? So now, let's do the reflected point that we just came up with, -4, -4. Does everybody agree that it would go here?
Yes.
Okay, so according to my ordered pair, that's where the red point is. And look, it was now reflected down across which axis? The x-axis, which is what it told me to do. So when I reflect across x, I take the opposite y value. So guess what we're going to do on the second one?
Reflect off the y value.
Reflect across y, so I do the opposite of x. 4, 4. Okay, so now it used to be -4, and now I do 4. How do I know? My line of reflection tells me which value is going to be the opposite. If I reflect across x, I take the opposite of what, class? Y. If I reflect across y, I take the opposite of x. And that's going to take a little bit of practice, okay? And that's okay. As soon as you figure out which one is the opposite, there's no math to even do. All right, we just switch them around. All right, so let's plot it on the graph and we'll be done. Over 4, up 4. And I just want to show you the green point. Guess where it goes from original to new? It reflects across y, which is what it told me to do. All right, are you with me more or less? Are you following what we're doing here? Okay, so now we have 2 examples where we're going to look at this. Actually, we have 3, but the first one is just a matter of, you guys remember on the translations where it was, look at the picture and is it a translation? You guys remember that? So you have a section on your homework tonight where it's, look at the images, is it a reflection? So all you have to say is yes or no. All right? Just do like a really rough sketch if you can of these 4. You don't have to copy the original on your homework. You can just say yes or no. But as you're sketching them, I want you to ask yourself, is this a reflection across that line that you see with the arrows? That's your line of symmetry or your line of reflection. Okay? Is this a true flip? Is it a true reflection? All right, so for A and for B and for 1 and 2, is it a true flip across the line of reflection? As you're drawing them, we're going to talk about each one in just a sec. Okay, let's look at A. I mean, this one kind of starts off a little tricky, and you almost want to kind of like hold it with your hand and like kind of try to visually flip this 2D image. All right, but if the red, okay, so you go red to blue. If blue is a reflection, so we're going from red to blue, is this a flip across that line? Yes, it is. It is a flip, okay, because this bottom point on the red, if it were to flip, it is going to become the top point on the blue, okay? It's a flip, all right? Do you see that? I know it's kind of hard to like grab it on the screen and show you how it flips, but hopefully that more or less makes sense. Okay, so all you have to say is yes. Okay, that one's yes. All right, what about B? No, what is it? We just learned it. It's translation. It slides. Okay, so B is no. It's actually a translation. So a section on a quiz or a test like next week would be some images, and you're going to tell me, is it a reflection, is it a translation, is it a rotation, what is it? All right, number 1 on the next section over, what do you think, yes or no? No, again, it's a translation. All right, what about 2? Yes. All right, how'd you guys do on that? Did okay? Yeah, it's a flip because you can see that the long side is close on both sides to the line of reflection. All right, any questions? Any questions? So really the key here is it a true flip across the line of reflection? All right, here we go with example 2. Okay, you do not have to write down the phrase up here. How do I know just by looking, but this is what you do need to write down. All the reflecting x-axis and y-axis. How do you know what shape this is without even reading? Okay, it is a triangle because there are 3 ordered pairs, which stands for each point on the triangle. We call that point a vertice. I know it's just a fancy word for a point, okay? All right, so here's what I want you to write. Reflect x-axis, leave a space for your new ordered pairs, and then we're going to reflect the same ordered pairs across the y-axis. All right, what our instructions say, and this is just like I think it's number 22 on your homework, is draw the image, and then reflect that image across the x-axis and the y-axis. I need coordinates to do that. So I'm going to come up with my coordinates, then I'm going to draw the image and the reflection. All right, so go ahead and copy that down. This is one that you're doing a graph on, so make sure you have a graph numbered and ready to go. Okay, so if you don't have your graph set up completely yet, that's okay. Let's focus now on reflecting our ordered pairs in the x-axis. Remember what we said in that first slide that we went over. If we're reflecting across x, we do the opposite of the y value. So if our original pair is 1, 1, I need to do the opposite of y in my new pair, so it becomes -1. So now it becomes 1, -1. Okay, so we're going to go 1. And remember to do that little apostrophe after A, and that just means that it's the image. We call it A prime. All right, for B, I want you to do B and C now, reflecting across the x-axis. All right, so what is going to be the new point B? Someone raise your hand and tell me. Gabe?
1 and -4.
Perfect. 1, -4. And what is point C? What's point C? Kennedy, did you get it?
C prime 3 -4.
Perfect. 3, -4. So now that I have my original coordinates that were given to me and my new coordinates for my first reflection, let's go over to our graph and let's graph the original 3 coordinates. So here's a perk for both reflections being with the same order pairs. You only have to draw one original one. Okay? So Let's go A1, 1. So if my first number, and this is just going to be a quick review for those of you who might still be a little iffy on the ordered pairs, my first number tells me which way to go on which axis.
The Y.
No. First number in the ordered pair tells me to go positive 1 on X. So I go right 1, and then where do I go? Up 1, because my second 1 was positive on my original ordered pair. So I go right 1, up 1, and I label it point A. Okay, I want you to do B and C for the original triangle. Go ahead and do B and C on the original. Okay, so did you go over 1, up 4? Do you guys have your point B there? Okay, what about for point C? Are you over 3, up 4?
Yeah.
All right, so now solid line connects our original image. Solid lines, A, B to C. Okay, now let's do our x-axis reflection, okay? Those 3 new ordered pairs that we just found the coordinates for. So for A prime, now I go over 1, down 1 for my A prime. See what I did there? Okay, my new point was right 1, down 1. All right, now you do B prime and C prime. And remember how you connect your dots on the image? Is it a solid line?
Dotted.
It's a dotted line, all right? Did you go over 1, down 4, and over 3, down 4? Okay, and dotted line connects them. All right, and now what we see here is a flip. Do you see the flip from purple to green? It is a true flip across, mission accomplished, the x-axis. Okay, so to reflect across X, we take the opposite Y values. All right, so now we're going to do the exact same thing, except now we're going to reflect across the Y axis. I want you to try to come up with your ordered pairs. Let's do the first one. A, my new A prime. Okay, to reflect across Y, we do the opposite of what was it, guys? X. So if it was 1 in the original order pair, now it's negative 1. And I leave my Y value the same. All right, go ahead and do B and C. Ayana, what did you get for point B?
-1, 4.
Yep, very good. -1, 4. And let's see. Caden, what'd you get for point C? Yeah, very good. -3, 4. And now we're ready to graph the image for the reflection across Y. Okay, so I want you to go ahead and plot these 3 ordered pairs. Again, we don't have to redo the original, so that's the perk for doing both reflections on the same graph. So all of this is happening on the same graph. Go ahead and do your last reflected image. Okay, so we go -1, up 1. I just did a different color. And guys, you're welcome to do that on your homework. Some of you maybe want to get creative. You can do that. Just be careful if you're using pen, all right? Because if you mess up, ooh, that's kind of a bad thing, all right? It can make your graph look sloppy. All right, so -1, up 1, -1, up 4, -3, up 4, dotted line to connect. And from original to new, what axis did you cross? The Y axis. So that's a reflection, a true reflection across the Y axis. And guys, do you see that it's the same size? We didn't change the size of the figure. It's the exact same size. It's just a flip across one of the lines of reflection. All right? Got it? Okay. All right, so let's do example 3. Example 3, you know, they always try to kind of tie it into some type of a real life example. This one's a t-shirt, okay? How do I know this is a pentagon? If it didn't tell me, because there's 5 points, and we know that a vertices stands for 1 point. So that does tell me that it's going to be a pentagon. So what I'm going to do is I'm going to try to find the reflected ordered pairs first. Guys, and that's really like my advice to you is to find your ordered pairs first and then put it on the graph. Okay? But how do I know which one to do the opposite of? How do I know if I'm taking the opposite X values or Y values? What do you think is going to tell me? So let's read the problem and we'll see if anything jumps out at us. A graphic artist designs a t-shirt using a pentagon with the following 5 vertices that you see listed. The artist reflects the pentagon in the y-axis to create the design. Find the coordinates, then draw the design in the coordinate plane. Anybody see anything jumping out at them that would maybe tell them which value you need to take the opposite of? Jason?
The artist reflects the pentagon in the y-axis.
The y-axis. So if you're reflecting in the y-axis, which value are you going to take the opposite?
Yes.
X. So look at the first one. Well, the first one really isn't going to help us a whole lot. Okay, because what's the opposite of 0, guys?
0.
It's just 0. So point P on both is going to be the exact same point, 0, 0. There is no such thing as a negative 0. Okay, but if I'm reflecting across Y, okay, let's look at point Q. I want you to write what you think would be the new point Q, or Q prime. Okay, yes. Okay, so since I'm reflecting Y, do the opposite of X, so now it becomes 2, 0. Very good. All right, so go ahead and do R, S, and T. All right, go ahead and do your reflected coordinates for R, S, and T. All right, let's see. Jamie, what did you get for point R? The new point R. The new point R would be what? Help her out, guys. 1, 3. Is that correct? Yeah, 1, 3. All right. And then what about my new point S? My new S. Avery, do you have your S yet? No, not yet. Kayla? 4, 3. Okay. And what about T? What about T? Morgan, do you have T?
Yes, ma'am. 0, 7.
Yeah, 0, 7 again, because you can't take the opposite of 0, so it's just 0, 7. So that's nice because P and T are going to be the same point on my graph. So when you plot that on your graph, guys, just go ahead and label the same point, P and P prime. All right, so you're just going to kind of label it on either side, P and P prime. I know, it's just all this technical vocabulary. All right, now let's do point Q, the original Q and the new Q. All right, don't connect these lines yet either because I have to give you one more tip. All right, the original Q is negative 2, 0. And the new Q is 2, 0. And you're going to see that with all these points, they're like the exact opposite on either side of the axis that you're reflecting. All right, try R, S, and T. Just plot your points. That's all I want you to do is plot your points. Do not connect any points yet. Let's go ahead and get the rest of the points. Point R, point S, and point T. And then we come back down the other side, R, S, and T. So how do we know how we're supposed to connect these points? You follow it in alphabetical order. So P, Q, R, S, T. Follow it in that order. The original. Okay, so P to Q to R to S to T. All right, and you're going to do the same thing on the other side. P, Q, R, S, T, dotted lines for the image. All right, just kind of sticking with that same concept. And there we go. What's going on the front of that t-shirt? An arrow up. It's really deep, guys. I know. There's an arrow on the t-shirt. Okay? Moving forward, maybe. Is that what it's saying? I don't know. Who knows? All right? But it's just this whole concept of reflecting ordered pairs. Could we have done all of these ordered pairs reflected across the x-axis? Could we have flipped it down? Yeah, we could have. Okay? All right. And if you understand that, that's everything you need to know for section 11.2.
Because it's